Welcome back. This is going to be a review of mean absolute deviation with 3 practice problems that we're going to go over. What I would recommend for materials that you might need to complete this would be a piece of scratch paper, as well as a graphing calculator, or your basic calculator would also work for this. We're going to get started on this first problem. The first problem says the data represents the height and feet of 8 different buildings. So we know, since it says 8 different buildings, that we're going to divide our answer by 8 when we're solving for the mean and solving for the mean absolute deviation. So first, step 1 is going to be to calculate the mean. To calculate the mean, what I do is I add all 8 of these numbers together. What I'm going to do is go into my calculator and add these numbers together quickly. So it would be 53 plus 47 plus 56 plus 48, and so on. So I should have gotten 408 as my total, but don't make the mistake, that's not your mean. That's just your total when you sum those 8 numbers together. Once I have that, I'm going to divide that by 8 because it told me that the total of buildings in the data was 8. So I'm going to get the number 51. 51 is my mean. So I'm just going to write that right here, that my mean is 51. We're going to need the step for 51 for step 2. Now what we're going to do with that 51 is we're going to take that to step 2 and we're going to subtract that from all of our data points. So again, we talked about this a little bit earlier. Whenever we take 51 and subtract it from each of these, it's going to give us an integer. If that integer is negative, we're going to make it positive because see where it says distance from the mean? There's no such thing as negative distance. So we're actually going to take the absolute value, which means it will always be positive. All right. So again, we're going to subtract 51 from each of these. So 53 minus 51 is going to be 2. 47 minus 51 would be negative 4, but we're going to write down 4 because remember, it must always be positive. 56 minus 51 is going to be 5. 48 minus 51 is going to be 3. 45 minus 51, 6. 54 minus 51 would be 3. 59 minus 51 would be 8. 46 minus 51 would be 5. Now, again, if you'd like to do this on your own, you can pause this part of the video to go to step 3 on your own. I'm going to go ahead and move on to step 3, which is where I actually find the mean absolute deviation in the next step. Step 3, we're going to calculate the mean absolute deviation. To do that, what we're going to do is we're going to take all these numbers that we found on the bottom set of the table, the distances, we're going to add all of them together. And we're going to divide by the total number of points that we have, which, as we stated a little bit earlier, it says up in the problem there are 8 points, which means after we're done adding all these together, we're going to divide by 8. Now, if I go to my calculator real quick and I add these numbers together, which I'm going to do now for you. And I got 36. So again, don't make the mistake. 36 is not our answer. 36 is just our mean distance. Once I've got 36, I need to divide it by 8, which, again, going back to my calculator, I'm going to get 4.5, which means the answer for my mean absolute deviation, or MAD, would be 4.5. Again, if you have any questions about these steps, you can always back the video up so you can see how I did these. But we're going to go ahead and solve one more problem. On the next problem, you'll notice that there are actually two data sets that we have to add together and solve for. But before we get to that, let's talk about how we compare mean absolute deviations between two different data sets. How do we do that? Once we're done and we've completed the MAD, we're going to talk about that in just a second. In this one, there's a chicken farmer who wants his chickens to all weigh about the same weight. He is trying two types of chicken feed to see which type produces the best results. All the chickens in pin A are fed premium growth feed, and all chickens in pin B are fed maximum growth feed. The farmer records the weights of the chickens in each pin in the tables below. Which chicken feed produces less variability? When I see a word like less variability, all that's really saying is which one's changing less. When we think back to the word variable, we think of X, and we always talked about X in terms of equations being the thing that changes. So in this case, we want to know which one changes the least because it's more predictable. So what I'm going to do in my calculator is I'm going to add all of these numbers together for pin A first, and then I'm going to divide them by the number of data points, which if I count that quickly, I'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means when I'm done with each of these, after I've added them together, I'm going to divide by 10. Once I get that number, I'm going to put that number right down here for pin A. That's where the mean is going to go for that one. And then I'm going to solve for pin B and get the mean for that one and do the same process and get this here. I'm going to pause the video for just a moment to let you have a moment to do that. All right, so as you can see here, I have added pin A at the top here together, and then I divided it by 10. Now we divided it by 10 because again, there was 10 data points. So this right here was pin A. This was my mean for pin A, which is what I'm going to write on my paper, except whenever they give you a number that has a number in the 100th place or beyond, we're going to always round to the 10th place, which means we're only going to do one number after the decimal. So instead of writing 6.31, we're going to write 6.3. On the second one, we got 66.9. This right here is pin B after I have added those together. Then I'm going to divide that one number by 10 as well because that was, again, how many data points I had. Once I divide by 10, I get 6.69. Now, again, we're going to round this number to the nearest tenths place, which this 9 is going to make this 6 become a 7. So instead of putting 6.69, we're going to write 6.7 for our mean. So to review, going back to our slide, we're going to have 6.7 as the mean for pin B. And 6.3 for pin A. Now, that was all for step one, and I know that was a lot to put into your calculator, but we're going to have to do this just almost the same thing again for step two. What we're going to do is we're going to take these mean and we're going to subtract them from each of these. So again, here's step two. We're going to make little tables below this, and I'm going to write my mean in each of these boxes up here just to help me remember. And what I'm going to do is take these numbers and we're going to subtract them. So this right here, I'm going to do minus 6.3 all the way across. This one's going to be 6.7 on the bottom because that was the mean for pin B all the way across. I'm going to give you a moment to go ahead and subtract those, and then I'll resume the video in just a moment. Now you'll see here that we have calculated the distance from the mean for all of these numbers. Your table should look something like this. If it doesn't look something like this, that means you either added or subtracted incorrectly. So I would go back and review that. Now that we've done finding the distance from the mean for all of these different numbers, what we're going to do is finish and find our mean absolute deviation. Remember, to find our mean absolute deviation, what we're going to do is we're going to add all these together, and then we're going to divide by 10, because that was how many numbers we had in our data set. Sorry, that doesn't look like a 10. I apologize. Then the same thing on the bottom, we're going to add all these together and divide that by 10. Make sure you include the parentheses, otherwise you will not get the correct answer in your calculator. Again, I'm going to pause the video for this section, and then I will resume it when I have the answer in my calculator. That way it gives you a chance to do this on your own. So the mean absolute deviation for pen A should have been 0.51. The number you would have gotten after adding together would be 5.1, and then dividing by 10 would give you 0.51 as your mean absolute deviation for pen A. Again, I'm going to pause the video for just a moment, let you complete this same process for pen B. So this is pen B right here, and we got 9.7 after adding the 10 together, and then after dividing by 10, we got 0.97 as the mean absolute deviation. So our mean absolute deviation for pen A, again, was 0.51, and for pen B was 0.97. So reflecting back on our original question, which one of these had the less variability? Now, the one that has the less variability is the one that is closest to 0. So in this case, the farmer would have preferred an A. What that means by less variability is that the majority of his chickens were close together at 0.51. The higher the mean absolute deviation, the less accurate it's going to be. So again, in this case, if we're comparing the two together, we're looking for the lowest mean absolute deviation if we're looking for the least amount of change. So to kind of conclude this, will a smaller mean absolute deviation always signal less variability? Yes. The smaller the mean absolute deviation is, the more accurate the data set is, and the closer each data point is to one another.